So today, like I said, is factoring polynomials. Can you say the word factoring? Factoring. Oh, I didn't hear enough people say that. Say the word factoring. That is what we're going to be doing. If you see the word factor or factored form, we're dividing polynomials by a very specific method. We're getting it into two little parentheses. Okay? And so what I'm going to do every time you see the word factoring is I'm going to put little parentheses around it. Because when we're done factoring, our answer, oops, that's not how you spell factoring, should have two little parentheses around it. We're going from a large polynomial to two smaller polynomials. This is going to be backwards double distribution or backwards box method. So the quiz that you just retook, we did some multiplying on it. We're going to do the opposite of that, which means we take a large polynomial and make it smaller. There's like 18,000 different methods to factor a polynomial. The method that we use at Mesquite High School is called swing and divide. What is it called? Swing and divide. It really should be called divide and swing because swing is the last step, divide is like the third step. So divide and swing is technically what it should be called, but it's funner to say swing and divide. Here are the steps. It's already filled out on your notes, so you have a really nice example here. But we're going to factor, and remember, factor means putting the thing in two parentheses. We're going to factor this polynomial right here. 6x squared plus 13x plus 5. The steps are to set up your own X puzzle. Remember, your homework was just to solve all of those X puzzles. Well, we're going to use those X puzzles as we factor these trinomials. The way that you set it up is the following, and I want you to circle these two things. In the top of your X puzzle is A times C. The bottom of your X puzzle is the letter B. And then I want you to put an A underneath it right here next to the 6. So to be clear, to set up your X puzzle, I'll just write it again. I think you should too. This is A times C. This is B. And we're going to divide by which letter? A. Okay, that's the setup for an X puzzle. Now you're probably like, Miss Quigley, where in the world do A, B, and C come from? It's a great question. It comes from the trinomial itself. This number right here, what number is that? 6. That's A. What's this number right here? B. Just the number, just the coefficient. B. That's going to be B, yeah. 13 is B. And then what's C? 5. Wow, I just wrote a 5. C. So A, B, and C come from your standard form polynomials. A is next to the squared term, B is next to the x term, and C is the number by itself.
So it's just always...
There's no D.
So it's going to always just be left, right?
If it is in standard form, yes. If it's out of order, either put it in order so it can be A, B, C, or know which one is A, B, and C. For the most part, it will be in order. I don't really plan on asking you things that are out of order, but there's a possibility it's out of order. Okay? So when we set this up, we did 5 times 6. What's 5 times 6?
35.
What? 30, which is why 30 is in the top. What's the B value? 13. That's why 13 is in the bottom. And what's the A value? 6, which is why 6 is underneath those denominators there. Okay, now we learned last time how to solve these X puzzles. So we would have made a chart for 30. 1 times 30, 2 times 15, 3 times 10. Does 4 go into 30?
No.
And then 5 times 6. Since the top number is positive, am I going to put a plus sign or a minus sign? Plus. Okay, so I'm going to add all of these. That's 31. That's 17. That's 13. That's 11. Which one has the number that I want?
3 plus 10.
Do I need to change any signs? No, which is why you notice they have a 3 and a... Whoa, what? They have a 3 and a 10 listed right here because those are the numbers out of my X puzzle. All right, we've solved the X puzzles. It says divide the factors by A. This is the divide part of swing and divide. What is 10 divided by 6? 5 over 3. We're just reducing the fraction. And what's 3 over 6? A half. Sometimes those become whole numbers. Sometimes they just don't really change because you'll divide by 1. No big deal. Now you need those numbers because we're going to take those numbers and we're going to pull them down here to be a part of my two little parentheses. We're going to say x, because that's the letter we're using, plus this number, close parentheses. And then x plus this number, close parentheses. The last step is to swing. We're going to take the denominators and swing them forward. Like just tuck them in right there in front of the x. So that my factored form is 3x plus 5 times 2x plus 1. That's factored form. My hands are doing parentheses every time I say factored form. This is how we want our answers to be written. Now here's the thing. Remember, these are equivalent expressions. So if I were to take the question that I have a box around and the answer that I have a box around, what would Desmos look like if I typed both of them in? The same. Let's prove it to ourselves right now. I want you to type the question from the top and the answer from the bottom and make sure that they are equivalent expressions. Fabulous. Thank you for checking that with me. Okay, last thing we're going to write on the front page here. It says, because we are writing what are called factored form expressions. And remember, I'm going to put parentheses around these words to remind myself that I'm trying to get it where there's two parentheses, factored form. We just did this. We can check our answers. You can do this by multiplying out your answer or by comparing the graphs of your answer and the given trinomial in Desmos, which is what we just did. It is possible that a trinomial may not be factorable. Do y'all remember last time we had one example that was not factorable? Why was it not factorable again? Do y'all remember? That last example on our notes, we couldn't divide it by anything, right? They didn't have any GCF. They weren't divisible by the same number. That's totally possible for a trinomial as well. And what's going to happen is you set up the X puzzle and just literally not be able to solve it. That's when you know that it's not factorable. Okay, let's do some practice problems to kind of iron out these steps here. You have the steps on the other side if you need to flip it back over, but we're going to do some of these together. Okay, we want to write an equivalent expression by writing the expression given in factored form. Everybody right now put parentheses around the words factored form, because we're trying to get it to where it's in its two factors, factored form. We're dividing. First thing I need to do is set up an X puzzle. When I do these X puzzles, what do I do for the top of the X puzzle? Flip your paper over. What does your note say to put on the top? A times C goes in the top. So what is the A value here? Ooh, it's the coefficient of that term. What's the sneaky coefficient? 1. So 1 times what goes in the top? 1 times 15 goes in the top, so 1 times 15 is 15. What goes in the bottom? Oh, not the denominators, the bottom of the X puzzle. 8. B for bottom. Bottom, like the little Despicable Me characters. No? Okay. Thought that would get some giggles, but that's fine. So the middle number, B, goes in the denominator. What letter goes underneath the fraction bars there? So 1. Okay. Now it's a regular X puzzle. When we were doing the X puzzles for your homework last night, we found all the factors of 15. So help me out. In an organized fashion, what are the things that multiply to 15? 1 times 15. 3 times 5. Is there anything else? No. Now 15 is a positive number. So am I going to add or subtract? Okay. 1 plus 15 is 16. 3 plus 5 is 8. Which one of these rows solves my X puzzle? Do I need to change any signs? No. So I'm going to put 3 and 5 solving my X puzzle. Fabulous.
That's all you gotta do.
Well, I mean, to solve the X puzzle, yes. We reduce the fractions. What's 5 divided by 1?
5.
What's 3 divided by 1?
3.
These numbers, the 5 and the 3, get to pop down and go in my factors, in my parentheses. And guess what? I've got it in factored form. It's in factored form. I need the parentheses. Yes, sir. Yes. So she just asked, I thought there was a number that's supposed to swing up under the X. That only happens if there's a denominator here in the last green step. Do you have denominators here? No, so we don't have to swing anything. I mean, technically it's a 1, but it's not.
Great question.
That was a good question. So that swing step only happens when you have a fraction in your parentheses. That was a good question.
I did a good question.
Yeah, we had fractions on the other side. Okay, let's go to example, LOL, look at how these are numbered. Let's go to example 6.
Why'd you number them like this?
I just messed up. I can count, right? I can count. We're going to example 6. Okay. Before we really get started here, let's first look at the polynomial. What's the a value for this polynomial? Oh, it's just the coefficient. So 4. What's the b value? Negative 12. What's the c value? 9. Okay, so again, we're getting those from here. A, B, C. Okay, we set up an X puzzle because we're trying to factor or write an equivalent expression. What two numbers am I multiplying to make the top? 4 times 9, which is?
36.
36. 4 times 9 is 36. What goes in the bottom? Negative 12. B for bottom. And then in the denominators, what numbers go in the denominators? That's where the 4 goes. Okay, that's the setup. Let's pause on the setup. What are your questions on setting up these X puzzles? Why do we have to multiply? That's part of the swing and divide method. You're multiplying the first number times the last number. So first number times last number, A times C goes in the top, and B the middle number, B for bottom. And underneath the fraction bars is the first number. Okay, what do I do next?
Set up a list, 36.
I do a list for 36. Okay, my list for 36 in an organized fashion is 1 times 36. Does 2 times 18 does 3?
Yes, 3 times 12.
4 times 9. What else? There's something else.
Is it? No, not 5.
6 times 6. Okay, great. That's my whole list because I already repeated a number. Now, is 36 the top number? Is it positive or negative?
Positive.
So I'm going to add all of these rows together. That's 37. That's 20.
If the top number is negative, then you subtract.
Yes, ma'am. If the top number is negative, you subtract them. I almost just started subtracting because we were talking about subtracting. Hee hee. Okay, so which row do I want to use? Okay. Now, here's the problem, though. My bottom number is negative 12, and I got positive 12 when I added these. What do I do?
You gotta switch the sign. Negative.
Switch the sign. Both of them are negative. Fabulous. Yes, you just simply switch the sign. So if you have the correct number over here, but it's the wrong sign, just change the sign of both of your factors. Make them their opposites. Okay. What's the next step? Divide. Negative 6 divided by 4 is negative 3 over 2. And that's the same over here. Now these numbers are the ones that get to pop down into my factors. We're going to do x minus 3 over 2 and x minus 3 over 2. Now question, why did I put minus instead of plus? Because they're negative. If the number you're pulling out of your X puzzle is positive, then you put a plus sign. If it's negative, you put a minus sign. Now, am I finished? No, because what do I have on this problem? Denominator. So I'm just going to swing that denominator forward, which means my final answer here is 2x minus 3 times 2x minus 3. Now, you may see the answer written like this, but actually mathematicians are going to simplify this problem. This one's a little complicated. Because 2x minus 3 is repeated, how many times is it repeated? It's repeated twice, so we can use an exponent of 2 to say that that parenthesis shows up twice. If you answer with this one, I'm going to give you full credit, but I need you to know that the test writers and most math books and mathematicians will write it as the second option. They're both correct. One is just more correct than the other. Probably the second one. But it makes sense. You've got 2x minus 3 showing up twice, which is why there's a little 2 there. Wow, that was a really complicated problem. Let's take a second and digest it. All right, let's do some more examples. I think we just need to do another example and then maybe find some more questions to ask, okay? Y'all are helping me out here. What's the A value? 1. What's the B value?
7.
What's the C value?
Negative 30.
-30. Very good. So we have an invisible 1, a +7, and a -30. Let's have Anicia, help me set up my X puzzle. What goes in the top?
Negative 30.
-30, because 1 times -30 is -30. And Anicia, what goes in the bottom?
7.
7. And then underneath my denominators, what number goes there?
1.
Very good. Fabulous. Okay. Adrian, what comes next? I've set up my X puzzle. So-
Make a list for negative 30.
I make a list for, 30 or -30. I'm going to put my negative there in a second. So that's 1 times 30.
2 times 15.
Uh-huh. Keep
3
going.
times 10.
Uh-huh.
5 times 6.
Fabulous. Is there anything else? No, because then we start repeating. Now you're right that this is a negative number. So just like a question was asked earlier, since that's negative, I'm going to subtract all these numbers. 1 minus 30 is negative 29. Yeah, keep going. You got it.
Negative 13. Negative 7. And negative 1.
Okay, so while none of those are the correct exact number, which row do I want to use?
7.
Okay, but they're the wrong sign. So instead of +3, -10, what do I use?
Negative 3. Negative 3. Negative 10. Or positive 10.
Yeah, I've got to switch both. So since 3 was already positive in this row and 10 was already negative, to switch the sign, I switch the signs. Okay, great. David, what do I do next?
You divide the fraction.
Great, so 10 divided by 1 is 10, and -3 divided by 1 is -3. What's after that, David?
Oh, you put
In the parentheses. How would I write that? Tell me exactly what to write.
X plus 10.
Now, class, do I have to swing anything on this one?
No.
No, I'm actually done right there. And remember, every single one of these is an equivalent expression. So when you're done with a question, what should you be doing as a student with your computer? Check your answer. You should not get one of these wrong, especially on a multiple choice test. We're going to do one more together before I have you do one on your own. So this is the last time to ask any questions. We're going to do number 11. LOL at how I numbered these, right?
Ooh,
Okay.
Oh.
What's the A value here?
4.
4. What's the B value?
You don't have one.
We don't have one, so what number should I use for B?
9.
Ooh, 1 is when you see an X, it's a coefficient, but if you just straight up don't have anything, what number should I use? 0. 0 is the nothing number, 1 is the invisible number. What's the C value? 9. I'm going to write that down because I think it's kind of confusing on this one. So A is 4, B is missing, and C is -9. There's no middle term, so it's missing. Okay, so when I set this up, Angel, what goes in the top?
Your 4.
I'm
Just 4? Flip your paper back over. What do I multiply to put in the top?
Once you multiply
I'm going to multiply which two letters?
4, A and C.
A and C. So I'm going to do 4 times,
-9.
and 4 times -9 class is -36. Heaven, what goes in the bottom?
0? No.
Heaven is going to answer. B goes in the bottom. So what number is B this time? 0. And then, Glenn, what numbers go underneath the denominators?
4.
4. Fabulous. Thank you.
This guy thinks I'm dumb. This guy thinks I'm dumb.
Quickly, I have a question.
Yes, Miss
I'm
Jackson.
super confused.
Okay.
How did you know that the B was 0 and not C?
Can anybody answer Miss Jackson's question?
Because the C always has the X line.
Say that again?
The B always has an X.
The B always has an X attached to it. So if there's nothing that has just a regular X attached to it, it's missing. So it's 0. Thank you. The letter C is always by itself. So you see how that -9 is straight up by itself? That's C.
Because there were only 2 terms in the original, so one of them was missing. I was just trying to figure out how she knew it was the B value.
Yeah.
It's gonna be 6.
Does that make sense? Okay, in the meantime, since I just paused, did y'all make a list of 36? I see some people did.
Yes.
Okay, read them off for me.
1 minus 36.
It's literally like
2, 18. 3, 12. 4, 9.
Fabulous. Okay, now you're right. I heard somebody say negative. So we are having a negative 36 on top, which means I'm going to subtract all of these. I'd get negative 35,
Oh, put 36.
negative 16, negative 9, negative 5, and 0. Don't let arithmetic be the reason why you're missing these. Use a calculator if you can't do that in your head. So I've got 0, which means I'm going to have 6 and negative 6. Marissa, what do I do next? What's my next step? After we fill the number in here, what do we do with those? Marissa, what do we do? Divide. Fabulous. So I'm going to divide. That's negative 3 over 2. And this side becomes positive 3 over 2. Okay. I'm going to bring these numbers down. So it's going to be x plus 3 over 2 and x minus 3 over 2. Am I finished with this problem once I bring those numbers down? Why not? I got denominators. I have denominators on both, so both denominators swing forward. It won't always be both. It might just be one denominator, and that's okay. Swing it forward. This is going to end up being 2x plus 3 and 2x minus 3. Can I simplify this one into one little thing with an exponent? Why not?
Because they have positive and negative.
Very good. They are technically different. One is positive, one is negative.
When you have to put a 0 in the problem, is it always going to be B or is it going to be A?
It is never going to be A.
Yeah, 'cause you can't make a mistake.
And if the 0 is C, then we don't factor like this. That's just them two things going to have a GCF. So we go back to what we did last time. So maybe, but in this process, if B is 0, you do this. If C is 0, you don't have to do this because it's just got a GCF. That was a really good question. Okay, so what we're going to do on number 5, or number 8, LOL. This one's for you. I gave you extra space in case you needed to erase and try again or write really big. This one is for you to try, and we're going to be coming around and looking for very specific things while you work. In fact, let me show you what I'm looking for here. I am looking for, the first time I come around, that you can set up your X puzzle correctly. The second time, I'm going to be looking to make sure you can solve the X puzzle correctly. And the third time I come around, I want to see it written in factored form, which is with the parentheses. Okay, those are the things I'm looking for as I come around. Are there any questions?
No.
Okay, I want you to start working on number 8. Thank you for trying. So again, let's walk through how to do this. So we're going to set up our X puzzle. Class, what number goes on top?
You know.
We can't see.
Oh, you're so right. Embarrassing. What number goes on top?
No.
What?
Negative 6.
Negative 6. What number goes on bottom?
5.
And what number goes in my denominators? 2. Okay, fabulous. I want to make a list of numbers for 6, which is 1 times 6 and 2 times 3. But since this 6 is negative, I'm going to subtract these numbers. 1 minus 6 is negative 5. 2 minus 3 is negative 1. Which row do I want? And are they the correct signs? 1 and negative 6, yes, because I got negative 5. Okay, what's the next step? Divide 1 by 2, you get a half. Divide negative 6 by 2, you get negative 3. These are the numbers that are going to come into my parentheses. It's kind of a dramatic arrow, but, Okay. This is x in a positive 1/2 and x in a negative 3. But I can't leave my answer like that. Final answers, what do I do? Swing it forward. Which means my actual final answer here would be 2x plus 1. Close parentheses, open parentheses. 1 x minus 3.
Are you okay?
I don't know.
She didn't drink her coffee today.
Words are hard. Okay, this is the process that we're going to be using. I love factoring. Honestly, it is so much fun to me. And there are like a bajillion and a half different ways to factor. So if you Google online and you learn factor by grouping, or you learn the guess and check method, as long as you tell me that's what you're doing, I'll let you use those methods. Otherwise, this is the method that we're going to be using.
Are there really bajillions of ways to?
No, I probably know personally 5 different ways to do it. I'm just being dramatic by saying 5 billion. But I need you to know one more thing, though. There are polynomials that cannot be factored. What's going to happen is if you cannot solve their x puzzle, and you've tried, and you're like, honestly, does this not work? It might be not factorable. That's going to happen like 1% of the time. So you're not going to have more than like 1 that's not factorable. Most of them can factor, especially the ones we're
Is
choosing.
there anything else you can do today?
Yes.
What are we done today?
Okay.